evening. I never know if this thing starts recording right away or if it takes a few minutes to actually kick in, because it gives me this little loading thing. No, I don't want to customize it. Okay, I think we're officially live if we haven't already been. It's been a while since I've come on here and done a Facebook Live video, and every so often, after deep digging into scientific journal articles and listening to some really great podcasts and lectures, and after I finish a few new books, I start to get so full of exciting information that I just have to talk about it in some sort of sphere. And with limited social interactions and scenarios where I can have those discussions with people, social media is a nice outlet for those discussions. So I wanted to give a little preempting warning that I definitely might be kicking the hornet's nest a bit in what I want to discuss, but it's not out of any disrespect. It's only with the simple goal of creating debate and discussion that is respectful and just sharing information that I think is really critical to wrap our heads around and think about when we are creating our ideas and forming our stories around what creates health, especially given the times we're in for our environmental impacts and all sorts of things. So yeah, I am in, the question is really just won't be quiet, is I think do we really have the right story right now? Do we really have the right narrative that's being widely perpetuated around health in general? I don't think we do. I think we're telling a very outdated story. And I wonder what it would have been like to live just prior to 2,000 years ago or 2,000 years ago, when the first scientists came forward and said, whoa, 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 I think we've got this wrong. I think the Earth is round. And at that time, the established, accepted consensus was that the Earth was flat. And so the scientists who first started questioning that took a lot of flack, and it actually took several hundred years before it was generally accepted that the Earth is in fact round. And even 2,000 years later, to this day, we still have small groups of people who just refuse to look at that. So it is really a slow process sometimes to change ideas that have been deeply rooted for a long time. And when it comes to the human body, I think that there are a lot of really outdated ideas that are taking just too long for us to catch up and change a lot of our systems around them to come up to speed with what we're learning. So I think about in past examples of when things seemed like a really good idea at the time and they were proven out quickly after to be disastrous. I think of, as an example, the lobotomy. So the man who came up with the lobotomy won a Nobel Prize for it in, I believe it was 1949. Yeah, 1949. And by 20 years later, there was a whole bunch of civil rights movements, and that process, of course, became completely abandoned by almost everyone rapidly after that. And it was quickly, now, I mean, today, if everyone saw the movie or read the book One Flew Over the Cuckoo's Nest, that was largely about the whole lobotomy thing. So today it's considered one of the most barbaric medical practices that ever happened. But at one time, when the inventor of it won the Nobel Prize, it was a really exciting thing. And they went from that, in, I think in 1946, having 100 of them performed in that country, and I can't remember, it might have been the US. And they went up to 5,000 by the year that he won the Nobel Prize in 1949. And then only 20 years later, it was a big whoopsie. Actually, that was a terrible idea, and we have a lot of better alternative treatments and approaches that we could be using. So that's just one more example. The first person to suggest that we should wash our hands before touching dead bodies that were covered in formaldehyde and chemicals and then delivering a baby was given scrutiny and made fun of and mocked for suggesting that we should wash our hands between touching dead people with chemicals on them and then putting our hands the doctor's or midwife's hands into a person to help deliver a baby. So even something as simple as washing our hands was given complete rudeness and from the medical community originally. So it's really hard to present new ideas in our society when we become really rigid in our thinking and things become like a belief system. So we have so many people that are true experts, scientists, doctors, epidemiologists, people speaking out and saying, hey, whoa, I think we need to broaden our view on this so we can have a better outcome from all. But instead of an open discussion and debate and the nuance being shared, there is a silencing and a censorship in the wrong direction for ideas that are definitely not harmful, like talking about stress, talking about sleep, talking about nutrition, talking about toxicity, talking about environmental devastation and how that affects people and our innate immune systems. And in fact, it's becoming taboo and dangerous for certain medical professionals to even talk about the innate immune system and admit that it's a thing, as if that is an off-limits topic now, which is, of course, ridiculous, especially when it's coming from people who've had decades of medical training. So I think that we are telling the wrong story when it comes to health, and stories are powerful. Words are a way that we put form into our thoughts, and then we can share those images and those ideas, and they start to take root in people's minds, and people start to live through those stories. So it's important when we have a narrative wrong, or we realize that a story needs to be shifted, that we actually try to keep an open mind, even if it's triggering, and have those discussions and not jump to that hateful, angry place for people just voicing some concerns or some questions. So our current narrative around health has really largely been focused on a lot of things that science has actually been proving completely out of date. So we know what we need to update a lot of our policies, but it's exciting, some of the things that are coming down. Like, we used to think that the human cell was the absolute center of health, and that if you just had healthy human cells, that nothing else mattered. We used to think that our adaptive immune system, which is the part of our immune system that creates antibodies, we used to think that that sterilized the body. So now finding out that, actually, our 50 trillion human cells are completely outnumbered by the virome, by 1.5 quadrillion bacteria, by hundreds upon millions of fungi and other parasites and other organisms that call us home. And not only are we home to these things, but we're completely dependent on them and our relationships with them for health. So we now know that it's not the human cell that's the center of health, it's the relationship between a healthy and thriving, diverse population of microbiome and virome in the body. So that's definitely one way that we have to reintegrate our thinking when it comes to what we're doing to the environment and what we're doing to our bodies in relationship to how we are making a good home for these various microbes. Sorry, my kid is making a big banging noise outside, and I don't know what that is. Check it out after. I wrote some notes because I didn't want to forget where I was when I was speaking. We based a lot of our conclusions, and we have been basing a lot of our conclusions about health and human biology based on what's been happening in sterile test tube situations. But our body doesn't function like that in real life. We don't have sterile conditions. We have relationships with microbes, and we need to have tests that can actually measure those relationships and that don't reduce the complexity of the human body and its interactions to a single test. Because it's not functional. We need to have tests that are functional, that are actually measuring a broader context of what's going on. Talked about that. So I find it very interesting that if you look up the definition of nature in the dictionary, that we have, as humans, we've written ourselves out of the definition of nature. actually, like, go Google right now, and don't take my word for it. Google the definition of nature, and you'll see that the typical Oxford Dictionary definition of nature is basically anything that isn't human, or anything aside from us, or or that we have. If we've created it or it's us, it's not nature. So it's very bizarre that we completely remove ourselves and separate ourselves from the definition of nature. And we know that that also is wrong. That's a false story, and we need to change that, because we are dependent on nature and part of it, and it's an integral relationship piece that we need to bring back, that understanding. And maybe if we really saw ourselves as part of nature and as in a partnership with taking everything in that spirit of reciprocity, of giving back and tending and caring, we wouldn't be in the mess we are now with environmental destruction of our forests, our oceans, our water, or everything. So I find that very interesting. I have a couple quotes to share. The first one is Carey Mullis, who incidentally is the inventor of the PCR test. And he once said in an interview, "If you can't figure out why you believe something, then you'd better make it clear that you're speaking as a religious person." So definitely a lot of the narrative that we are following right now in the story is being done in what seems almost like a scientific dogma or religion of some kind, because we really don't have the proof and the scientific evidence to justify what's going on. And in fact, there is a lot of evidence on the contrary that should be shaping our policy in a very different direction that's being ignored. So I just want to bring up a few things that I'm learning and that I found very fascinating at any rate, and maybe you will too. Another quote before I delve into that is chemist and Nobel Prize winner Walter Gilbert. He once criticized the scientific community, saying, "The community as a whole doesn't listen patiently to critics who adopt alternative viewpoints. Although the great lesson of history is that knowledge develops through the conflict of viewpoints, and that if you have simply a consensus view, it generally it diminishes it. I don't know what I wrote there. It fails to see the problems of that consensus, and it depends on the existence of critics to break up that iceberg and to permit knowledge to develop." So another point being made by someone with a lot more credentials than I is that we have to maintain the scientific debate and that criticism and the ability to question a hypothesis. And that's how we drive our knowledge and drive our understanding forward, is by questioning. If we just accepted as truth everything that was once believed, we would never have kept progressing and kept learning to where we are today. So it's good to have an open mind and open discussions and debate, and not be very closed-minded and dogmatic in our thinking. Okay, so I just want to talk a little bit about the virome in response to our own genomics. I think a lot of people don't understand or comprehend the sheer volume of genomic information as far as viruses that are within us and surrounding us at any given moment. So in the air, every time we breathe, we are breathing in 10 to the 31 viruses. So that's 10 with 31 zeros at the end, viruses in our air at all times. Where was I here? A single gram of soil contains 10 to the 9. So if a gram of soil from outside, that's 10 with 9 zeros of different viruses in it. A liter of seawater has 10 to 10. So a liter of ocean water, 10 to the 10 viruses in it. And the adult human body has 10 to the 15 different viruses in it. So that's 10 with 15 zeros at the end. And even a 1-week-old infant, so at the end of that first week of life, that brand new baby has, for every gram of feces or stool, 10 to the 8. So literally hundreds upon millions of viruses in that healthy baby's stool at any given time. And that baby is perfectly healthy, and that baby is not sick, that baby is fine. That's every single baby on this planet. And I think that's fascinating, because that baby doesn't even have an adaptive immune system yet. The human doesn't make any adaptive immune system until between 3 and 6 months of age. So you've got this perfectly healthy baby that has millions upon billions of bacteria and viruses in its intestines, in its feces all the time, and that baby is just healthy and growing exactly how it should be without any ability to make antibodies whatsoever. So I just find it fascinating that when we are surrounded, every breath we take, every drop of water, every drop of food, every interaction with the natural world and our own bodies, we are coming into contact with millions and millions and millions of viruses, and yet we think that only a few of them are out to get us, and that we need to declare war on the natural world in order to win this war, this battle, when really they're not even alive. They're just little bits of genetic information, and that's what's around us, is just this sea of genetic information that we come from, and that's keeping us in relationship with nature at all times. So 50% of our genes, our human genome, 50% of those genes were actually inserted by viruses, and it's estimated that 8% of that is from retroviruses. Our viral genes, actually, viruses gave us the ability to even be mammals. So not only humans, but all mammals, that ability came from viruses. And 3 really important ones in particular. Without viruses, there's these 3 special ones that they've discovered. The first is that we wouldn't even be able to have a placenta if it wasn't for viruses. Viruses gave us the ability to create a placenta. They also gave us the ability to have fertilization occur. So there would be no fertilization for mammals if we didn't have viruses in our genome. And the other one is we wouldn't have stem cells if it wasn't for viruses. So viruses updated our genome to allow for stem cells. So that, for me, is just a clear indicator that we are in a sea of viruses, a sea of genomic information that's constantly helping us adapt and change and be in relationship to what's going on in our environment and driving evolution forward. And it just makes me feel relieved. It really takes away any of that fear piece if you think about just being in right relationship and being surrounded in that information and kind of being updated all the time. It's almost like a Microsoft update, if you will, for the human body. So the virome is an information stream coming out of biology as a whole. So every living thing on the earth creates viruses, and viruses are the ability to move that genetic information between species as needed. And it's the individual body that makes the decisions on whether or not to integrate that viral information or not. We're finding out now that the ribosomal transcriptase is one of the most heavily complicated pieces of human biology, if not the most complicated that's been discovered yet. I think I write notes on that further on, so we'll touch on that. But definitely the purpose of the virome is adaptation and diversification. So what if the way we interact with nature today is the way in which we interact more intelligently tomorrow? So the interactions we have today with people, with plants, with the earth itself, with our food, that's putting us into a different relationship for how we'll be able to adapt tomorrow. So we know every life form is capable of producing viruses, and that they're just packets of genetic information. That's all they are. And experts have long talked about endogenous viruses that form inside of our cells in response to stress factors. So there's another huge branch of science of the learning of exosomes. So exosomes are created inside of cells, often in response to toxins or other stress factors. And the exosomes are sent to all of our other cells, and they change our genetics. And they're also exuded out of our bodies, and we exude this cloud of exosomes that can be picked up by other people. They're not the same as viruses, though. Although the line between exosomes and viruses is really blurring, and there's a lot of of having to go back through old literature because we really didn't know about exosomes before, to be able to tell the difference between what is an endogenously created virus or what is an exosome, and how do we tell the difference. So it's really complicated, but it's just important to note that stress and toxins and environmental chaos drives adaptation, because we need to be able to adapt to those changes. So when we are under environmental stress or toxins or some sort of shock factor, that, or plants or animals or whatever organism is, that's when viruses can be created or when exosomes can be created, and that genomic information is constantly being spread back into the greater environment. Nobel Prize winner and geneticist Barbara McClintock, in her 1983 paper, showed that genetic material of living beings can constantly alter by being hit with shocks, which are toxins or stressors, and this leads to the formation of new genetic sequences which were unverifiable before. And when she came out with her theory about genes being able to shift because of the environment, she was heavily scrutinized and ignored, and the scientific community was largely hostile to her for a very long time before they finally had to admit that she was right. I think in 1979 is when that happened. So it's just another example of when we think we have all the answers, and we're unwilling to look at things from a deeper perspective or question what we know. We lose an opportunity to deepen our learning and assimilate that knowledge and just be smarter and act more intelligently on a whole. I wonder if there's anything else I want to say about exosomes there. I just find it interesting. Coronaviruses, in particular, have been around for 780 years, and there are lots of them. We know of a handful that have historically infected humans, and so with what's going on right now, it's for me, it signifies more that we have a problem in the environment, because in every case of any pandemic or crisis in which a virus is blamed, there are also environmental factors to look at, like what is going on with the air, the water, the soil, what is going on in the environment that would lead to this genetic information causing problems with health. So maybe it's not actually, maybe, a lot of doctors and scientists are actually coming forward now and saying, whoa, it's actually not the virus itself that's causing any of these problems. It's our relationship to health in general and our innate immune system is failing, and we're not able to integrate that genomic update, and we're having down the line side effects from not being able to adapt properly to get in relationship with that information again. So it's something to think about, instead of putting all our eggs in one basket and declaring war and only focusing on this one thing. Why aren't we talking about stress and sleep and nutrition and what strengthens the innate immune system? And why aren't we talking about the fact that we've got billions of different viruses surrounding us or in us at any given moment? And why only now is this one becoming a problem? What is really going on? Is it actually the virus itself that's causing this, or is it the relationship to the body and the environment and what's going on that's preventing biological functions from being carried out in their optimal conditions? There's a Dr. John Gilday. I wanted to mention him because he has some very interesting work. He's worked on human genetics and decoding the genome, and also he's done a lot of work actually for the military with germ warfare and things, and trying to create solutions before attacks could be had. And so he had a lot of really interesting things to say about exosomes, for one, but also just the brilliance of the human nasal passage and what happens when you breathe through your nose effectively. So anyone who's interested in learning more, I highly recommend John Gilday's work. And then, of course, Dr. Zach Bush and Dr. Peter Cummings. They are both triple board certified physicians. Zach Bush is mainly he worked as an endocrinologist, and then Peter Cummings is a neurologist, and hearing both of their perspectives is very interesting as in regards to the innate immune system. But a lot of people don't realize that our entire being really is an immune system. It's working with the microbiome, it's working with the virome, it's working with the nervous system, it's working with our endocrine system, and it's extremely sophisticated and complicated, and it doesn't boil down to, oh, just get more vitamin C or just take that shot and you'll be fine. Like it's just so much more complicated than that. But our immune system can sort of be divided into two different classes of the innate immune system and the adaptive immune system. And right now, almost all of the attention has been on the adaptive immune system. And that's because that's the one that creates antibodies. And that's the one that we don't even gain until 3 to 6 months of life. And when we actually get an infection, our innate immune system is what clears that infection, and we don't even produce antibodies until 3 to 5 weeks after that infection is already cleared from the initial infection time. So it's not like antibodies are the thing that's clearing the infection, although a lot of us still have that image in our mind of us getting sick and then these antibodies going to battle and clearing it for us, when actually they show up long after the innate immune system has already taken care of it. So our innate immune system is a regulatory system that controls the ways in which we utilize genomic information from viruses, and our adaptive immune system makes downstream decisions with not viruses, but the proteins that we make or produce from them. So according to developing understandings that our current science has, RNA ribosomal transmission and regulation is the most complicated and highly regulated step in human biology of anything we know so far. Over 200 different proteins have to be present to turn on the transcription factors that will allow a ribosome to take RNA and turn that into a protein, and another 80 proteins are there to suppress the activity of that ribosome. So there are some doctors out there who are saying that our cells are actually fully capable of deciding whether or not they want to take in a virus and whether or not they will make proteins from that piece of genetic information or not. And that it's not the story that we get of they're hijacking our immune system and that we have to be at war with them because they're taking us over. That's just not what's actually happening from another perspective. So a virus only ever stays in our system for a few days. So it's not like you have virus for weeks and months and months and months of being sick. The highest it gets is when you're symptomatic, and then it diminishes. It's the innate immune system that will bring you back into balance with that genomic information in 3 to 4 days. Any sickness, inflammation, fevers, all those nasty symptoms that we hope we don't get, that can happen over the following weeks. And when that does, it's the virus is already gone. When you're actually reacting to is an inability to adapt. So if you're at risk of great harm from a virus, then that's demonstrating that you do not have adaptive capacity. So it takes 3 to 5 weeks after infection before the adaptive immune system makes antibodies. I mentioned that. So the antibodies have almost nothing to do with clearing the virus. That's the innate immune system. But if you get sick from a virus, what that means is that your body did not have the reserves of antioxidants, clotting cascade factors, etc., and nutrients that it needed in your dysregulated, depleted, diminished, and exhausted state, and you end up with a syndrome like COVID-19 as a result. And what the adaptive immune system does is change our adaptive relationship to protein synthesis of the new gain of function we get from the virus. So in the event that your innate immune system is dysfunctional and you can't decide at a cellular level which protein you're going to make at any moment accurately, then it will try to help you if you're overexpressing some proteins. So that's what the adaptive immune system is doing. It's keeping things into balance downstream. If you start to overexpress certain proteins, that's when it comes in and calms that down. I think that's all. I think that's my notes. So yeah, just to sort of sum up, we are in a sea of information all the time. Our own body is constantly updating our own genomics based on what we're eating, how we're feeling, what we're thinking, our interactions with sunlight, with breathing air, with what we're eating especially. Of all the things we can do any day on any given moment, what we put into our mouths is what we have the most control over, and that is giving your body direct information about the environment that you're going to not only feed yourself, but you're actually feeding your whole microbiome, and the fungi and bacteria that we rely on are getting nourished or not from that food. So thinking about our innate immune system and what strengthens that, it's nutrition, it's rest, it's sunlight, it's exercise, it's time in nature, time with loved ones, laughter, hugs, sex. All those things that we live for is what is strengthening us. But pollutants and toxins and stress and overwork and tons of time being sedentary and watching things that stress you out and not exercising, and all those things are actually crippling the innate immune system. And yeah, I just wanted to talk about those new perspectives that are coming up that give me a lot of hope and inspiration into recognizing that the problem that we see with our food and our environment and our forests and our soil erosion and our acidification of the oceans and all these things have a direct impact not only on this external part. We are so connected to it in so many ways. And I think that's all for my ramblings for now. I actually have to go pick up my toddlers again and find out what that big bang was outside from the 12-year-old. So have a great night, everyone, and hopefully, yeah, if you guys have anything to pop in the comments to discuss. I want to post a few images from some screenshots of studies. If anyone wants to look up some of the studies that I was mentioning, then I will put that there so you can go and reference those for yourself. Don't just take my word from it for it. And yeah, let's have a polite discussion with no jumping down anyone's throat in a hateful way. Have a good night, everyone.